Hello everyone, my name is Vanisa Tudu from third year ECE department. Today I will be explaining pulse code modulation or PCM, which is one of the most widely used methods in digital communication. Modulation is defined as the process of changing the carrier signal's parameters by the instantaneous values of the message signal. There are many modulation techniques which are classified according to the type of modulation employed. Among them, the digital modulation technique used in pulse code modulation. So here the explanation of PCM block diagram. First we pass analog message signal through low pass filter. Then low pass filter removes high frequency noise and limits the bandwidth of the input signal to avoid during sampling. Then sampling takes samples of the analog signal at regular intervals and output discrete time analog signal. Quantizer approximates each sampled value to the nearest fixed level, converts continuous amplitude to discrete levels. Next, binary code converts the quantized values into binary numbers. Then, parallel to serial converter, combines binary outputs into a signal serial bit stream for transmission. Next, channel, which is the medium through which the digital signal is transmitted. Serial to parallel converter reconstructs the parallel format from the received serial data. Decoder converts binary values back into quantized analog levels. Then reconstruction filter smooths the decode signal to approximate the original analog waveform. At last, reconstruction signal final output, the reconstructed version of the original input analog signal. Consider the analog signal xt. The signal is first sampled, then assigns closest level, then it becomes quantized signal. Quantization in PCM, the process of measuring the numerical values of the samples and giving them a table value in a suitable scale. Amplitude is varying from 0 to 1V for 3 bits per sample. Total sample L equals to 2 to the power n. If n equals to 3, then L equals to 8 samples. Voltage difference in between samples equals to delta V by L equals to 1V by 8 equals to 0.125 volt. The finite number of amplitude intervals is called quantizing interval. There can be two categories, linear quantization and non-linear quantization. Difference between sampled output and quantized output is quantization distortion. To decrease the distortion, we can increase number of labels by increasing number of bits. There are two types of quantization, mid-trade and mid-rise quantization. The main difference between these two techniques lies in the way the quantization levels are distributed. In mid-trade quantization, the zero level is placed exactly in the middle of the quantization range, and the positive and negative levels are distributed symmetrically around it. In contrast, in mid-rise quantization, the zero level is not included in the quantization levels, and the positive and negative levels are distributed asymmetrically around it. Signal to quantization noise ratio (SQNR). The signal to quantization noise ratio of the quantization is defined as S by N equals to signal power by noise power. The noise power is given as mean square value equals to expectation of epsilon square equals to epsilon square bar. The mean square value of a random variable x is given as x square bar equals to expectation of x square equals to minus infinity to plus infinity x square fx x dx. Here expectation of epsilon square equals to minus infinity to plus infinity epsilon square f epsilon epsilon d epsilon. Expectation of epsilon square equals to sigma epsilon square equals to minus delta by 2 to delta by 2 epsilon square f epsilon epsilon d epsilon equals to 1 by delta minus delta by 2 to delta by 2 epsilon square d epsilon equals to delta square by 12. When load resistance R equals to 1 ohm, then the noise power is normalized. Noise power equals to V square noise bar by 12 equals to delta square by 12. Expressing the signal to noise ratio in decibels. S by n equals to 10 log 10 S by n less than equal to 10 log 10 3 into 2 to the power 2v less than equal to 4.8 plus 6v decibels. Bitrate and bandwidth of PCM. Bitrate of PCM can be calculated by bitrate equals to n into fs, where n is bit per sample and fs is sampling frequency. Bandwidth is depending on type of encoding is used. Digital signal requires more bandwidth, but we pay price for roundness and digital communication. Advantages of PCM: uniform transmission quality, compatibility of different class of traffic in network, integrated digital network, increased utilization of existing circuit, good performance over poor transmission path. Disadvantages of pulse code modulation: large bandwidth requires for transmission, noise and crosstalk leaves low but attenuation will increase. Applications of PCM in compact disc, digital telephony and digital audio processing.